Question 22 of the final review. So we're talking about a binomial experiment. And so first it's trying to get us to remember what the rules are of a binomial experiment. So bi means two, and so there's going to be two mutually exclusive outcomes for each trial. There will be a set or a fixed number of trials. The outcomes, the trials are independent of each other. They do not affect one another. And the probability of success is the same for each trial. So it looks like this one is what I just said. Oh, wait, what did I look? Two mutually exclusive outcomes, fixed number of trial, outcomes do not affect each other, the probability of success is the same. Okay, so now we're trying to find exactly 4. And anytime we're computing a probability, we will be in calculators. And so we'll go to stat, calculators, and then we're talking about a binomial. And so in other questions, it might say that it's normal, and so you'd go to normal. You just go to what the words say. And it already told us that it's a binomial, so that's where we're going to. Our n is the total number, so in this case, it's 25. Our probability is this percentage, so 0.63. Always put percentages in into decimal form when you're in StatCrunch. And then we want exactly 14. So x equals 14. No more and no less. And that is our probability right there. So now we'll just times this by 100. And we want to pick the one that's exactly 14. And then we want at least 17. So at least 17 means that you can have 17, 18, 19, all the way up to 25. So it's 17 or more. So x is greater than or equal to 17. That one confuses a lot of people because it says at least, so you think less than, but at least is actually greater than. And then the same thing, you would just times this number by 100, and you want 17 or more, the one that we calculated, and be 38. And now we want between, so we click on between, and it saves our number and proportions. And then we change it to 11 and 14. Oops, I didn't mean to put that decimal at the end. And then the same thing, you times it by 100 or move the decimal place over 2. We want we want between 11 and 14. And now we're going to compute more than 22. So we'll go back to here, and we want x. So it can't be 22. We want normal greater than, because 22 is not included because it just says more than. And so it's unusual when it's less than 0.05. And so it is unusual because the probability of this is 0.00, let's see, 4 decimal places, 11, which is definitely less than the 0.05. And if we times this by 100 and round to the nearest whole, or we move the decimal places over twice, we're saying it's going to be 0. And so that's pretty unlikely.